Hello, and welcome to one of my favorite number sense talks. You are about to embark on a journey designed to help you construct an understanding of very large numbers using our most famous irrational number, pi. Before we begin, you remember pi? For every circle in the world, pi is the ratio of circumference to diameter. If you were to do the actual division, no matter what circle you chose, you would get the exact same number every time. The number you would get is this. If you did the long division, you would find that it would never end, ever. Eventually, you would have to give up. But some people just won't give up. Last I heard, pi had been calculated up to 1.2 trillion digits. I don't know about you, but I find that number hard to imagine. Just how big is 1.2 trillion digits anyway? This is the very large number we will investigate today. Look at the number 10. It is 2 digits long. I made a sample of a 10-digit number, and on my screen it appears to be about 2 inches long. The number 1.2 trillion is 13 digits long. Here's a sample 1.2 trillion digit number. And now it's time for our journey. Let's imagine that we could print out all 1.2 trillion digits of pi that have been identified. Let's print them in a font where every character is 1 millimeter wide. There are no spaces and no commas. In other words, we will have a strip of paper 1.2 trillion millimeters long. Let's lay it out on the sidewalk or on the street in front of the school. Try to visualize how long you think it might be. Think about a millimeter. A millimeter is pretty tiny, isn't it? How long could this possibly be? If you were to walk it from beginning to end at a normal pace, how long do you think it would take? Without calculating it, jot down your best guess now. We will also need to review a concept that I call fancy forms of 1. Basically, anything divided by itself is equal to 1. Another way to say it is that any two values equal to each other and divided by each other will equal 1. Writing them in the other order is still equal to 1, such as 1 foot over 12 inches. We will use this concept to write a conversion formula. First, since the digits are in millimeters and walking speed is measured in kilometers, we need to convert the millimeter number to kilometers. I will do this in 2 steps. I build one form of 1 using the fact that there are 1,000 millimeters in 1 meter and there are 1,000 meters in 1 kilometer. How did I decide which unit goes on top? Because I know that I wanted unneeded units to cancel out. Oh, that's stupid. The millimeter units cancel each other out, and the meter units cancel each other out, done in red and blue. Next, we can cancel out trailing zeros. This is done in green and in yellow. We will multiply what is left, so pi is 1,241,100 kilometers long, when the digits are each only 1 millimeter wide. But how long will it take to walk 1,000 kilometers? Well, let's go see the rest of the story. We can convert this distance to time needed to walk it by multiplying by the walking rate of 5 kilometers per hour. I flipped the form of 1 to be sure the kilometers would cancel out. Please take a moment and do the division now. So far, we know that it will take 248,220 hours. This number is not very meaningful to me, so I think we should continue our conversion to express it in day, months, maybe even years if necessary. In order to convert hours to years, let's use a familiar form of 1, like 24 hours in a day and 365 days in a year, writing each in such a way that the intermediate units get canceled out. I hope you will also remember to simplify the numbers before you start multiplying and dividing with ridiculously large numbers. There we go. Yes, it's true. You did it correctly. If 1.2 trillion digits, 1 millimeter wide each, were laid side by side, and if you took a walk along the trail of numbers, it would take you 28 years and 4 months. That is with no stopping, sleeping, or anything.
Now let's just think a minute about a trillion. What is going on in the world today that we measure in the trillions? I'm thinking about the national debt. Now, how long do you think it's going to take us to pay that off now that we have a good idea or a better idea of how much a trillion really is?
Thanks for watching.